Okay, so today's lecture is on the distance formula. And the question we're trying to answer today is, what is the distance between 2 points in the Cartesian coordinate system? That's your standard XY plane, and I'm going to abbreviate it CCS for Cartesian coordinate system so I don't actually have to write out the whole thing. Let's look at the distance between points, say, 1, 2, and then say the point 5, 5. It's about there. So we're looking for this distance here. So that's our question. What is our distance D between 1, 2, and 5, 5? So let's think about what we do know. We know this distance here. We're going to call this distance delta y, and delta y represents the change in the variable y. And we're calling that delta y in particular because for the moment we're assuming that this is our y-axis. So what is our change in y? Well, we've got a y of 5 here, and a y of 2 here. So the difference between them is 3. Our difference in the y direction here is 3. We also know this distance, which we're going to call delta x. Delta x, of course, represents the change in the variable x, because we're assuming that this is our x-axis horizontally here. So what is our change in x? Up here we have x being 5. And down here we have x being 1. So our change in x here is 4. And because of the way we've drawn this as a vertical line and a horizontal line, we know that this is a right triangle and its side lengths are 3, 4, and D. So what the Pythagorean theorem gives us is that D squared is 3 squared plus 4 squared, which is equal to 25. So D squared is 25, and D is 5. Now, D squared equals 25 has two solutions, positive 5 and negative 5. But we take the positive root because we want a length. So there's an example where we've found out that the distance between 1, 2, and 5, 5 is 5. Let's see what this looks like with more arbitrary points. So let's draw some axes. And now we're going to have a couple of points. We're going to have one point we're going to call x1, y1, so that's point 1. And we're going to have another point, it could be anywhere, and its coordinates are going to be x2 and y2. And this point we'll call P2 in case we need to reference it. So we're looking for the distance D between point 1, x1, y1, and point 2, x2, y2. Again, It's going to be easy to find our change in y, and it's going to be easy to find our change in x. And the change in y and the change in x and the distance d are going to form a right triangle. So the Pythagorean theorem is going to tell us that our d squared is equal to the change in x squared plus the change in y squared. What are our change in x and y? Our change in x is going to be the difference between the x coordinates, and our change in y is going to be the difference between the y coordinates. So our distance formula comes from the Pythagorean theorem. It says that d squared is x2 minus x1 squared plus y2 minus y1 squared. Notice that this quantity on the right is going to be positive, so taking the square root will not be a problem. And we see that our distance is a positive square root, because distances should be positive, of x2 minus x1 squared added to y2 minus y1 squared. And this is what is commonly referred to as the distance formula in 2 dimensions. But really, if you can't remember it, if you don't want to remember it, it comes from drawing a triangle and using the Pythagorean theorem on the triangle where the distance between the 2 points is d and the legs are the change in y and the change in x. So let's look at an example of how to find the distance between 2 points just using the distance formula itself. So say, what is the distance between let's just do -1, 5, and 3, -7. Well, the distance formula says that this distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So of course the question becomes, what is x2 and x1 and y2 and y1? And the way you decide this is you make one point, point 1 and one point, point 2. It doesn't matter which one. Let's say make this point up here point 1 and this point over here point 2. So the x1 and the y1 are the x and y coordinates of whichever you make point 1. And x2 and y2 are the x and y coordinates of whatever you make point 2. So if I make -1, 5.1 and 3, -7.2, then our distance formula gives us that our distance is the square root of 3 minus -1 squared plus -7 minus 5 squared, or the positive square root of 4 squared plus -12 squared, or the square root of 16 plus 144, which is the square root of 160, which simplifies to 4 times the square root of 10. What if instead I make 3 negative 7, 0.1, and I make negative 1, 5, 0.2. So that negative 1, 5 becomes x2, y2, and 3 negative 7 becomes x1, y1. Let's apply the formula to it. And we see that our distance formula now gives us negative 1 minus 3 squared plus 5 minus negative 7 squared. Or negative 4 squared plus 12 squared. But you know, that still just gives us 16 plus 144. Then take the positive square root so that we get the square root of 160, which is 4 times the square root of 10. So you see, we get the same answer no matter which point we choose as point 1 and point 2. The important thing is x1 and y1 are the x and y coordinates of whichever you pick as point 1, and x2 and y2 are the x and y coordinates of whichever you pick as point 2. Note also that your x2 minus x1 might end up being negative. Here our x2 minus x1 ended up being a negative 4, but it becomes positive once you square. So that is how you determine the distance between 2 points in the Cartesian coordinate system.